Well, hello everybody. Welcome to the Protecting Our Planet Through Science panel, where we'll hear the stories of some fantastic scientists, their careers, and how their work helps to protect our planet and fight climate change. So we'll be hearing from Rebecca Sawyer, who's an applied scientist working with climate data and a science communicator at the Met Office. We'll hear from Andre Gadwan, who is a research scientist at NOTPLA working to combat the problem of single-use plastics, and from Professor Jeanette Rochelle, who's an environmental scientist in toxicology at the University of Hull, and she's studying microplastic pollutions. But first of all, I'll give you a bit of a rundown of my career journey. So I think you can see my slides. I'll head over to those now. So I've had a bit of a varied career. I was born in the UK, born in Kent. But when I was only 5 years old, my family moved to Australia. They moved to a town called Wollongong, and that's south of Sydney. And so I went to school at a place called the Illawarra Grammar School. And then I went to university at the University of New South Wales. And then afterwards, I was looking for some experience overseas. So I moved to Italy. And then I ended up back here in the UK just earlier this year. So I'll go through why that happened. So this is me back when I was in year 7 in 1999. It looks like we only had black and white photos in those days, but it's not true. It's just that our school journal that year happened to be printed in black and white. And then below you can see me in my final year of school. I was always one of the smallest people in the year, but I was also one of the youngest. So, that's okay. And now when I was at school, I wasn't quite sure what I wanted to do later in life because I liked a lot of different subjects. I liked studying. I loved maths. That was probably my favorite subject, and I liked science, but I also really liked languages. So I did a combination of science and languages. So not knowing, I kind of changed my mind every day about what I wanted to do with my life, but I knew that I wanted to do something big, something exciting, and something unique. And I really like traveling as well. So that's where this quote comes in. I haven't been everywhere, but it's on my list. I really want to get to as many places as I can around the world. And at the same time, I have this really strong love of our planet and of the environment. So I wanted to make sure I was doing something to help there as well. So after school, I just decided to study engineering. And specifically, I was studying industrial chemistry. So I did this Bachelor of Engineering in Industrial Chemistry, and I had this special scholarship which allowed me to do a number of industrial training placements as well. So I worked for a while. I worked for 10 weeks at Sydney Water, which was an industrial wastewater treatment plant. I also worked for 10 weeks at Siemens Water Technologies, which makes membranes for water filtration. And I worked for a whole year at BlueScope Steel. So in Australia, all the roofs are made from steel, and they have to have coatings of paint to protect them from the elements. So that's what I was doing there. So I did actually really enjoy these industrial training placements. But in the end, I decided to continue my studies. My supervisor bribed me with chocolates and with the possibility of going overseas. And so I continued on and I did a PhD. So I did research. That's the title of my thesis, Core Shell Borohydrides for Reversible Hydrogen Storage. Probably doesn't mean too much to you. But basically what I was working on was nanomaterials, so very, very small materials, and using them for alternative energy, specifically for hydrogen cars. So as I said before, after that, I wanted to get some international experience. So I was looking for a postdoc, which is the kind of job that you often do after your PhD, after your doctorate. And I found one in Bologna in Italy. So I moved to Bologna. It was supposed to be for 1 to 2 years. In the end, I stayed there for 9 years. And these are some of my projects. So I was working on a material called graphene. And it's used for, above all, it's used for electronics. So it has to be very, very clean. And that's why you see me wearing this funny blue suit. I was working inside a clean room. But I also got to do this interesting project about space. So I was working on using this graphene material to coat materials for cooling devices in satellites. And that's why you see those photos down the bottom of me on a parabolic flight, so experiencing zero gravity. Now, during that time, I also spent a year in Antarctica. So I was at Concordia Station, which is a French-Italian base in the middle of Antarctica. You can see there all the different types of experiments that go on. Specifically, I was there to do atmospheric physics and meteorology. So nothing like the materials science that I had done before, but I had a lot of sort of transferable skills that I could then use to work in such a hostile environment on a completely different field. And it was really a life-changing experience. I had a lot of fun. It was tough. As you can see there, we got down to minus 104 degrees Celsius. There was extremely low air pressure, so only about 60 to 65% of the oxygen that we have at sea level, and also really low humidity. So it was tough conditions to live there. And we were with a small international crew of only 13 people for the 9 months of the winter season. And for 100 days of that time, it was always dark. So you can imagine the kind of difficulties that we were facing. And I had to go out to these labs, which are at the back of the picture here, and work outside every single day. So that was really, really challenging. Now, just to give you an idea of why Concordia Station is there, it was originally built in that location for a project called EPICA, European Project for Ice Coring in Antarctica. And what they did was they drilled this ice core, which is over 3 kilometers long, 3,270 meters. They cut it into small slices. And as you can see, in those small slices, there are lots of bubbles. And you can analyze the gases that are trapped in those bubbles. And you can correlate that with the depth, and that tells you the year, or approximately the year. And so you can map basically the composition of the atmosphere going back 800,000 years. And it's from this graphic, which is quite famous, that tells us that in the last 100 years, there's been a lot more carbon dioxide and methane in the atmosphere due to human activities. And in the same location, just a few, maybe 30 miles away, there's a new project called Beyond Epica, which is going to drill down and go back 1.5 billion years. So we'll get even more important information. So this was a really incredible experience I had to be able to contribute to the science, which is learning about our planet. And this all led me to apply for the European Space Agency astronaut class. Now, there were a lot of people who wanted to apply, and it was the first time that the European Space Agency opened up applications for 13 years. But I was amazingly, out of 23,000 people, I actually did get to be one of the final 17. So I'm very, very excited to apply my science, my scientific skills in the future to going on a space mission, hopefully. And these are the kind of missions that the European Space Agency has. You'll probably know about the International Space Station, which is an orbiting laboratory, does all sorts of fantastic science. We have missions going back to the moon. There'll be humans walking on the moon once again, and this time we're going there to stay. So we'll be building a station in orbit around the moon and then one on the moon itself. And then there are robotic missions to Mars. And in the 2040s, there will also be humans going to Mars. And so maybe one of you who's listening will get to go to Mars. So that's all from me. We will take some questions at the end, so you can stick them in the Slido and I'll see if we can get to them. But in the meantime, I would like to ask Rebecca to speak to us about her career journey.
Thanks, Megan. That's great. I'm just going to share my screen. Bear with me 1 second. Amazing. So hi, everyone. I'm Rebecca Sawyer. I'm a foundation climate scientist at the Met Office, and my main role is in the Urban Climate Services team. So that's where we work with cities in the UK to communicate to them about how climate change is going to affect their area and their cities in the future. But my focus has a particular focus on extreme rainfall, but I'll go into more detail about that. But before I do, I just wanted to talk about my journey and how I got there, because I haven't been at the Met Office for long. I've been here for a year, but it'll be great to explain a bit more about my journey and where I got there. So I am currently based in Croydon in London. I've lived here my whole life. I went to school there. I've grown up there. But I work at the Met Office, which is the UK's National Weather Service, for anyone that didn't know. And the office is based in Exeter. So it's a very long way away from London. But yeah, it's been really good to get to know a new city. But when I tell people I work for the Met Office, they usually say, are you going to be on TV? Talk about the weather. But actually, I'm a climate scientist, so we study how the weather is going to change. So it's about the long-term weather due to climate change. So it's not what you think. So my journey into science, I went to Coloma Catholic Convent Girls School in Croydon. I loved it. I had the best time there. And my hobbies when I was there was around tennis, running. I love sport, but my main passion was about drawing and painting. And I love spending time with my friends and family. So at school, I didn't really know what I wanted to do. When it came to choosing GCSE options and A-level options, I just went with kind of what I thought I was good at, and what I enjoyed as much as possible. So I went with art, geography, French, and health and social care for my GCSE options. I really, really enjoyed art. It was my favourite subject. So I was kind of leaning a bit more towards, going down the art route. And then for A levels, I picked geography, art, biology, and psychology. I also knew I really loved science at GCSE, but I kind of struggled with the thought of maybe doing all the sciences and maths. I didn't necessarily think I was clever enough to do that. So I tried physics A level, and I lasted about a week. And then I swapped back to psychology because I found it a bit too tricky. But that was okay. So how did I get from this to climate change and climate science? Well, it was actually a pivotal moment for me. I was in my geography A-level class, and one day my geography teacher at the time put on this documentary called Before the Flood by Leonardo DiCaprio. I don't know if anyone's seen it, but it's quite it came out in 2016, so quite a while now. But at the time, I didn't really know much about climate change. It was kind of covered briefly in topics. But when I watched this, I couldn't believe what I was hearing. It was the first time I went into some, depth about climate change and what was happening and how it was happening. And I couldn't really believe my ears. And I couldn't believe that if it was true, why it wasn't spoken about and enough, why it wasn't all on the news, why people weren't speaking about it. So it was a big moment for me, and I remember it very well. So I kind of had that in the back of my mind when I was choosing sort of what to do next after school. So after school, I decided to do BSc Geography. I wanted still to pick a subject that I enjoyed that would also keep things very broad, and it meant that I could do art and all the things that I love still outside. Um, I went to the University of Sussex, which was in Brighton, so that's yeah, south of the UK. I'm sure everyone knows, but I loved it. I had the best time, and I made sure that during geography, I picked the environmental modules, and it was the course for me. I really loved it, and I met the friends for life. But during my course, unfortunately, COVID happened, so I didn't get to maybe have the best use of uni time. So it was a good opportunity for me to go on and do a master's. So I actually finished my master's last year in August. So again, it wasn't that long, but I decided to go on and do a master's in climate change development and policy at the University of Sussex as well. So I stayed there, got to stay with some friends. And alongside that, I worked at an environmental charity called Brighton Peace and Environment Centre. So that allowed me to network and meet some amazing people, and also kind of contribute back. And it obviously was in my local area. And also, I remember going to my dissertation supervisor at the time, kind of talking about my, future and where I wanted to go. And I said I wanted to be a climate scientist, and she said to me, "Well, you can't be a climate scientist without learning how to computer code." And it kind of took me by shock, because I thought that that's something that I would never ever do. It kind of scared me, computer coding. But I had a go, and I did a small coding course alongside my degree. It was only 8 weeks, and it was quite fun. It was something for me to do, and something completely out of my comfort zone. But yeah, I really enjoyed it. So I did that. And then that led me to applying for a foundation scientist role at the Met Office. So I started last October, so I've just been there over a year. But my main job has been in the Urban Climate Services team. So my main project has been working on these rainfall information packs, so displaying sort of the climate change information for specific cities in the UK. teaching people about how the climate is going to affect extreme rainfall. So I really enjoyed it because it means that I can sort of communicate to people about the risks, but I can also do it in a way that, you know, I have to really think about how to communicate the science, you know, because it'll be going to people like local planners and, you know, the public and people who don't necessarily have, you know, high technical scientific skills. So I've also been able to incorporate sort of the art into it and sort of display the information in ways that really engage people. So I've really enjoyed that too, and sort of I've been able to use my computer coding to access climate models. But can I just say I've had to learn that along the way. It's been difficult, but very, very interesting. And then finally, I've also been doing some work in the knowledge integration team. And, you know, since working at the Met Office, it's been very apparent to me that the science, you know, all the papers that are being published are not finished until it's communicated to people who can actually use the science to make change. So the knowledge integration team at the Met Office work on communicating these complex scientific, you know, findings and papers into something very small and brief. And communicating in a way that they don't have to spend hours reading it, and they can get the key points. So a lot of the work we do in the knowledge integration team is producing infographics to get people's attention. I'm not sure if any of you would have seen these, but I'm not going to take credit for any of them apart from the top right hand side. This one is the one I did, but yeah, I really enjoyed it, and it allows me to sort of use my scientific skills that I've learned, communicate, feel like I'm making a difference, but also use sort of my art and my artistic side as well. So I've really enjoyed it. I feel like I'm making a difference, and I've been able to speak to so many amazing scientists and people who really want to use the information. So yes, it's been amazing. Thank you.
Thanks so much, Rebecca. That's super interesting and doing really, really important work that you enjoy too. So that's really exciting to hear. Now I'll ask
Thanks, Megan.
Andre, what's tell us about your scientific journey.
Yes. Let me just share my screen. You able to see my screen?
Not yet. Here it comes. Yes, there we go.
Okay. Right. Apologies about that. Is that okay? Yeah. So good afternoon, everyone. My name is Andre, and today I'm very thrilled to share my journey with you. From being a schoolboy in Borneo, the island of Borneo, to becoming a scientist at NOPLA, sustainable packaging. So at NOPLA, our mission is clear. We want to make single-use plastic packaging disappear. And we're inspired by nature. We use plants, we use seaweed as sustainable alternative to plastics. So we create packaging that naturally disappear, just like a piece of fruit. We chose seaweed as our main materials because of its many benefits. Seaweed grows rapidly, it's abundant worldwide, and requires minimal resources to grow. And as you can see on the screen, it's just some of the stuff or some of the packaging that we created at NOPLA. And like I mentioned, and seaweed is an amazing materials, and it helps take in carbon dioxide and makes the ocean less acidic. And that's few of the reasons that we use natural materials and seaweed in our packaging. But before I talk more about my work at NOPLA, I want to go back to the very beginning. So growing up in the island of Borneo, I was always surrounded by nature, the hills and the mountains and the great beaches. And as a child, I was also always curious how things are made. So in school, I love subjects like chemistry, biology, and physics. So during my A-level, I've taken like chemistry, biology, and mathematics. yeah, but after that, I wasn't sure like how all of these subjects would allow me to sort of like directly protect the nature. So I wanted to connect the dots. So in uni, during my undergraduates, I did polymer engineering. It's a rather applied course. I think this was mostly due to my passion for chemistry, and I always love chemistry and my fascination how things are made. And I have learned in depth the various methods of manufacturing processes to make even simple plastic products like plastic bottles or pipes and so many other products. But at the same time, this also, through the course, also inspires me to think about or look for greener solutions. What are the things that we can do to replace plastic? So after my undergraduate, I worked as a research assistant at an institute called Science and Engineering Research Center, where I did research on the use of natural fiber as ingredient to make materials stronger. And at the same time, I completed my master's degree there. And in 2017, I won a scholarship to do a PhD at Imperial College. So from the island of Borneo, I flew 10,000 miles to London. And it was my first time being in London. So it was a huge and terrifying thing to do, but it was really fun. And my doctoral and my postdoctoral research, I was looking into the use of different natural-based materials, such as waste fibers, nanocellulose, and all of these different waste byproducts to reinforce or to make a product stronger. And if you notice, I started uni in 2009 all the way to 2021. And that's a lot of years in universities, really. And that's a lot of like learning and researching. But I learned I learned a lot, and I improved my research skills, which includes planning and conducting many cool experiments. And last year I joined NOPLA as a research scientist. So my role at NOPLA is quite interesting. It involves transforming seaweed, as you can see on the left, to a more functional product. And to do that, it's quite challenging, but I feel like it's also rewarding. And understanding the behavior of like the materials, the natural materials that you use, and the chemistry of the materials that you use is crucial. So in my role at NOPLA, there is this fascinating cycle that I'm engaged in. It's never straightforward. So this is what I call the make, break, analyze cycle. First, I create materials, I blend seaweed and other natural elements, and invent new formulations and shape them into different products with different shapes or dimensions. And the fun bit, I think, was the breaking bit. It's basically testing these different products that you've made under tension, for example, and to make sure that they are strong. And also I test their compostability to ensure that they break in nature. And I'm proud to say that at NOPLA, our materials are strong as plastics, and it decomposes naturally, leaving no microplastics behind. And last but not least, analyze. I then analyze the results and the data. And this is a very important step because it allows us to sort of like understand what next step that we have to do. Do we need further improvement in our formulations? And this is the bit where we will decide. Often it's an iterative process. We will repeat this cycle until we solve all the challenges and all the problems. And to date, we have replaced more than 4 million tons of single-use plastic packaging, and we are looking forward to replace more. Me and my friends at NOPLA will continue to create new formulation, to invent new formulation, greener materials, and hopefully they will be in your hands very soon. If you would like to know more about NOPLA, feel free to visit our website, nopla.com. Thank you.
Thanks so much, Andre. That's really, really cool, and I can't wait to see the impact that these new materials will have on the world. They're ready to change the world. So very quickly moving on to Jeanette now. So please tell us about your journey and your work to protect our planet.
Thank you, Megan. So I'm Jeanette Rochell, and I'm a professor of environmental science, and I specialise in the field of toxicology. So toxicology is quite a complicated name, but it's actually the study of poisons. So I'm interested in how chemicals kill organisms, which isn't a very cheerful subject, but is something that we do need to study so that we can then prevent it and protect our planet. So in terms of environmental toxicology and these poisons, then how on earth did I start my journey there? Because it's not something I think at school you think you're going to become. So actually, when I was at school, at primary school, and then also at secondary school, I spent much of my time doing sports. So actually, I had photos of me being in the netball team and me also in the swimming team. And I would have said that at school, I was actually very much more interested in doing sport than anything else. And maybe if you'd asked me at that time, what am I going to do? I wouldn't have said science. I would have said, I'm going to be a PE teacher, perhaps. So you never can tell where you're going to go. I chose A levels based on the what I enjoyed. So I enjoyed biology, I enjoyed chemistry, and I enjoyed history. So I did something a bit radical and mixed up my A level subjects, and that was absolutely okay. I should also confess that I really struggled with mathematics as well, and I was a bit worried that if I become a scientist, will I actually able to cope if I can't do the maths? And the answer to that was yes, I could cope absolutely fine, actually. So after my A levels, I thought, right, what am I going to do next? So I just relied on what I'd done before, which is choose the subject that you enjoy. And I did a degree in biological sciences at Napier Edinburgh University. And I didn't do particularly well in my A levels, but at degree level, I did quite well. And I think there it was because I started to see the reason why we study organisms, how they work, or chemicals as well. So that was really interesting. I did quite well in my degree, and then I carried on with what had worked well, and I did a master's degree in marine science. And there I was interested at this point in the toxicology part, the poisons part. And for a project, I went out into the Forth estuary off the coast of Edinburgh and looked at the effects of oil on different fish in the estuary. And that was me hooked for the rest of my career. That's all I wanted to do at that point, was to look at the effects of chemicals on different organisms in the environment. So moving on from that, I did a PhD, and it gets very technical here. So I'm not just looking at fish and chemicals, I'm now looking at tumours in fish and how do the chemicals cause those tumours. So it's getting quite technical at that point, but I was really, really enjoying it. And the information that you learn from that can then help to perhaps prevent diseases in the organisms in those environments in the future. So that was going to degree level. And if I was honest, I wouldn't have said I was going to degree when I was younger. It was only because my friend who lived around the corner, who was a year older than me, decided to go to university that I thought, maybe I'll try that as well. So that's how I got into marine biology and the sort of study of poisons. So at the moment, what I'm doing is looking at microplastics. And microplastics are the small pieces of plastic. So the smallest you can't see, you'd need a microscope, but the larger ones are probably about the size of a sesame seed, so you would be able to see those. And microplastics come from the breakdown products of larger pieces of plastic once they end up in the environment. So you might have seen on the news or on the television information about plastic in the environment. So it gets everywhere. It's in the sky, it's in the clouds, it's in the marine environment, the deepest part of the trenches in the oceans, on land, and also in people. So we've been looking all these different places. What does that mean in terms of what we do in a job? It means sitting in the lab, doing lots of experiments again and again and again, and analysing the data and then presenting it to people who can then do something with that data. So on a day-to-day basis, it's a bit repetitive, but you need that data to be able to make any kind of influence and to bring about any kind of change. So that's microplastics. Our next project, which is very exciting, is in collaboration with an explorer, and it's Alan Chambers. He has decided to trek across Antarctica, carrying a sleigh and collecting snow cores all the way. And what we're going to do is analyse those snow cores for microplastics. What will that tell us? Why are we bothering to do that? It will tell us how the levels of the microplastics are in those Antarctic cores. And it will also give us information, perhaps, about where the microplastic sources have come from. So that, again, is really important information that can help us protect our environment. So that's it from me. Hopefully, I've managed to cope well without my slides. Back to Megan.
Thank you, Jeanette. I love that research. I mean, microplastics are such a huge problem that we're seeing, and it's come to the broader public through news articles and so on. So I think it's on everybody's mind, and it's so good to see the practical work that's going on around them. So we only have a couple of minutes left. I'd just ask, we've had a few questions come in. So just one sentence from each of you on what's the favorite part of your job. And I'm just going to add one for Andre. Is the seaweed packaging edible? Because that's come up a number of times. So I'll answer quickly. My favorite part of my job is learning about so many different things. I love dipping into lots of different areas, learning from my colleagues and hearing everything that's going on. That's my favorite part. Rebecca.
Yeah, my favourite part of the job is feeling like I'm making a bit of a difference and contributing to the how we support moving away from the climate crisis, and supporting moving away from climate change, and doing what we can in that sense.
Andre?
Yes, we do have edible packaging made of seaweed, and my favorite part of my work is to be able to apply all the things I've learned during school and during uni into my work.
Wonderful, thank you. And Jeanette?
It's also making a difference for me as well. So producing data, giving the data to the lawyers and the policymakers who then change how we do things.
Thank you. Thank you so much to all of our panel. Thank you to all of you for listening. The next session that is coming up is Protecting Our Planet Through Technology. This will start very soon. So you can just stay on this link and watch the next sessions. Thanks so much for being with us.